Welcome. Here I'm going to do an example where we write a number as the product of primes. This is also referred to as the prime factorization of a number. So I'll begin with an example. We'll do the number 120. So I like to make a little tree. My goal is to find all the prime numbers that together multiply to equal 120. So I'll make a little tree. I look at 120 and 120 and I say, well, it's definitely divisible by 10. So 10 and 12. So make my little tree. 10 is divisible. It can be 2 and 5. 2 and 5, I can't make those any smaller. They're not divisible by anything. They are prime numbers. That's what that means. So I'm done with this branch of my tree. Then I'll move over to my 12. I'll do again a 2 here. And then I have a 6 on the other leg. The 2 is a prime number, can't be divided any further, but 6 can be. It can be divided into 2 times 3. So now the bottom branches of my tree are all prime numbers. I have 2, 5, 2, 2, 3. And I'm going to take all these lower branches, kind of the terminal branches, and those 5 numbers become the product of primes, become the prime factorization. It's standard to write them in order. So I have 3 2s, in numerical order, smallest to largest is what I mean. So I have 3 2s, 2 times 2 times 2. I have a 3 here, and then also a 5. So this is the product of primes. We can also simplify this. Remember that repeated multiplication, that is what exponents are. So 2, I have 3 2s, which means I could rewrite this shorthand as 2 raised to the 3rd power. And then I would still have the times 3 and the times 5. So this would be the shorthand way of writing it. I would consider both to be correct, but if you are asked to use this format where you have the exponents, then that's what you should do. I want to do these exact same example, but with a different tree, because the prime factorization is unique. You always get the same answer no matter how you go about it. So let's consider a different tree. Let's say instead I looked at the 120 and I said, well, that's 2 times 60. So I'm starting with different values. I can't do anything with the 2. That's already a prime. It's not divisible by anything. The 60, I'm going to say, well, I have a 6 and I have a 10. And then the 6 is 2 times 3. Those are both prime numbers. I can't make that any smaller. And the 10 is 2 times 5. Again, I'm going to look at kind of the ends, the leaves of my tree, right? I'm looking at those terminal spots of my tree, and I'll write them again. So I still have 2 times 2 times 2 times 3 times 5. So no matter how you go about it, you will always get a unique answer for any individual number. Thank you so much for watching.